imagine a sky burning cobalt blue at sunrise. The air howls at 7,000 kilometers per hour. The clouds are not water, but vaporized rock. Something glints inside them, sharp and falling. It is glass, molten and screaming sideways. This world is real, and astronomers have seen it. It orbits a distant star 63 light-years away. Its name is a quiet code, HD 89733b. Beneath that calm name hides a furious blue inferno. Welcome to one of the strangest planets ever found. The planet is a gas giant, slightly larger than Jupiter. It hugs its star far too closely. A single year there lasts only about 2 Earth days. The orbit is brutally tight. It sits about 30 times closer than Earth from our sun. Heat saturates everything. Surface temperatures climb past 1,000 degrees Celsius. The atmosphere is a roaring furnace. There is no solid ground to stand on, only crushing, glowing gas swirling beneath you. Because the planet is tidally locked, one face always burns, the other never sees daylight. On the day side, the star never sets in the sky. It hangs eternal and merciless. On the night side, darkness reigns forever, yet even there, the heat barely fades. The temperature difference drives winds of astonishing violence, faster than any storm on Earth. In 2007, astronomers used the Spitzer space telescope to map it. They measured its heat directly. Then in 2008, Hubble unlocked a deeper secret. Astronomers studied the planet's color. They watched starlight filter through its atmosphere as it passed in front. The light carried clues. The planet absorbed red wavelengths and reflected blue ones strongly. A signature emerged from the data. HD 189733b glows a deep cobalt blue, like a sapphire suspended inside fire. It was the first exoplanet ever to have its true color measured, a truly historic discovery. But the color is not from oceans, as Earth's blue is. There are no oceans here. The blue comes from something far stranger drifting in the air, tiny particles of silicate dust. Silicates are the same minerals that, on Earth, form glass and sand. Here, they float as vapor. In the planet's scorching upper atmosphere, these particles condense into droplets. Tiny droplets of glass. These droplets do not fall gently like raindrops on Earth. The winds will not allow it. They are hurled sideways at speeds beyond imagination, faster than the speed of sound itself. Models suggest wind speeds of about 8,700 kilometers per hour. That is 7 times the speed of sound. For comparison, Earth's fastest tornado winds barely reach 500 kilometers per hour. This is another league. These hypersonic winds rage from the day side toward the night side, always trying to balance the heat. Imagine standing in such a storm if you somehow could. You would not stand long. The molten glass would strike like microscopic bullets, each one searing hot, polishing and burning at once. The sky above would not be soft and clear. It would shimmer with falling, glowing shards. And those shards would catch the starlight, glittering as they fly. A storm made of light. This is why the planet looks blue from far away. Sunlight scatters off the silicate haze. The same physics that paints Earth's sky blue paints this world's storms. The medium, though, is glass. It is a hauntingly beautiful coincidence of chemistry and chaos. 2 worlds, 1 color, very different fates. To stand on such a planet is impossible, of course. There is no surface beneath your feet. You would sink endlessly through layers of ever denser gas, each layer hotter than the last. Eventually, deep down, the gas turns supercritical. Neither truly liquid nor gas, but something between. Below that, pressure crushes hydrogen into a strange metallic state. A sea of liquid metal hides at the core. This is the secret heart of every hot Jupiter, a pressure cooker we will never see. But far above that hidden ocean, the storms keep raging, endless sideways glittering blue. In the upper layers, temperatures swing wildly between day and night. The difference is staggering. The day side can exceed 1,200 degrees Celsius. The night side hovers around 700 degrees. That huge contrast is what fuels the supersonic winds. Heat always rushes toward cold. On Earth, similar physics drives our jet streams. Here, the same physics is monstrous. Clouds form on the cooler night side, where vapor finally condenses. Glass droplets crystallize in shadow. Then the winds sweep them around to the day side again, where they melt and vaporize once more. It is a never-ending cycle of evaporation and storm, a weather pattern with no relief. The planet is what astronomers call a hot Jupiter, a giant gas world orbiting close to its star. It was discovered in 2005, around a star slightly smaller than our Sun. The star is named HD 89733A. The system sits in the constellation Vulpecula, near bright Albiero. You can almost see the star with binoculars. HD 89733b is one of the most studied exoplanets in history. We know it intimately now. Because it transits its star from our point of view, we can probe its atmosphere. Light tells us everything. Each time it passes in front, starlight filters through its outer layers. We read the chemistry. Astronomers have detected water vapor in its atmosphere. They have also detected methane and carbon dioxide. Faint traces of organic molecules drift in the heat, carbon-based compounds inside a furnace. None of it suggests life, of course. The conditions are far too extreme for biology. But the chemistry hints at complex processes happening in alien skies. A planet alive with weather. The night side, though hidden from its star, still glows faintly, heat carried by those terrible winds. Infrared maps show that the hottest spot is not directly under the star. It is offset, downwind. The winds drag the heat eastward before it can radiate away. The whole atmosphere is in motion. This was among the first weather maps made beyond our solar system, a real milestone for science. Each new observation reveals something we never expected. The universe rewrites our textbooks constantly. In recent years, the James Webb Space Telescope has turned its eye towards similar planets, sharper than ever before. It studies their atmospheres in unprecedented detail, layer by layer, molecule by molecule. Slowly, we are building portraits of alien skies we will never visit, worlds painted entirely by data. HD 189733b remains a favorite target for these instruments, a laboratory for understanding planetary extremes. Yet the strangest part of its story may still be ahead. The planet itself may be slowly dying. Its star bombards it with intense ultraviolet radiation and stellar winds. The atmosphere is being stripped away. Astronomers estimate it loses hundreds of millions of kilograms of gas every second. A planet evaporating. Over billions of years, the outer layers will thin and bleed into space, a glowing tale of loss. Some hot Jupiters end this way, reduced to dense rocky cores, ghosts of giant worlds. HD 189733b may one day become such a ghost, but for now, it burns blue and proud. The story of how we found it is itself remarkable. It began with a tiny dip in light. The host star briefly dimmed as the planet crossed its face. Detectives noticed the rhythm. That faint shadow, repeating every 2 days, betrayed the planet's presence, a heartbeat across light years. From there, every clue was teased out of starlight alone. We never sent a probe. We never will, at least not in our lifetimes. The distance is simply too vast. Yet we know its color, its temperature, its winds, its weather. We know its mood. That is the quiet miracle of modern astronomy. We touch worlds with mathematics. Light is the only messenger that can cross such distances, and light is patient. It carries fingerprints of every atom it has passed through. Each wavelength tells a story. When Hubble pointed at HD 89733b, it caught those fingerprints in detail, a faint spectrum of clues. From that spectrum, scientists reconstructed an entire alien climate, without ever leaving Earth's orbit. If you could see one alien world with your own eyes, which would it be? Tell me in the comments. Maybe a diamond planet, or a world drowned in lava, or this cobalt storm of glass. Whatever you choose, the universe likely contains something even stranger nearby. Reality keeps outpacing imagination. Before we discovered exoplanets, we imagined other worlds resembling the ones in our solar system, familiar variations. Rocky planets near their stars, gas giants far away, neat and orderly, echoes of home. But the universe laughed at our assumptions. It gave us hot Jupiters, ice giants in tight orbits, and lava worlds. It gave us planets with 2 suns, planets orbiting dead stars, planets squashed like footballs. Reality outpaced fiction. And it gave us a world where glass falls sideways through a sapphire sky. Imagination cannot keep up. More than 5,000 exoplanets are now confirmed. Each one is a story waiting to be read. Some are bigger than Jupiter, some smaller than Earth. Some are pitch black, some glow like embers. Among them all, HD 189733b still stands out, the cobalt jewel with razor rain. Think about what it means that such a place truly exists, right now in this very moment. While you read these words, somewhere in the dark, glass storms are raging. They have raged for billions of years. They will rage long after our cities, our languages, and our memories are gone, indifferent to time. The universe is filled with such silent dramas, worlds living and dying in fire and ice. We see only a sliver of them, the brightest, the closest, the most observable. The rest remain hidden. But every new telescope and every new technique lifts another corner of the veil. The map keeps expanding. We begin to understand that Earth, with its gentle rain and breathable air, is rare, possibly precious beyond measure. Our blue is the blue of oceans and sky reflecting sunlight. Soft, calm, and life-giving. HD 189733b's blue is the blue of vaporized rock and supersonic ruin. Beautiful, but utterly lethal. 2 shades of blue, separated by 63 light years and unimaginable conditions. Same color, opposite meanings entirely. To travel there at light speed would take a lifetime. We will never set foot there. But our instruments reach across that void, gathering whispers of photons. Science is long-distance vision. From those faint whispers, we reconstruct entire worlds. The mind stretches to meet them. This is one of the deepest gifts of modern astronomy, the ability to know without going. And the universe rewards that effort with wonders we could never have invented. Reality outshines every myth. A planet where glass rains, winds break sound, and the sky burns blue forever. All of it true. When you next look at a calm evening sky, remember it could have been otherwise. Earth is a quiet mercy. Somewhere, beneath countless stars, other skies rage in colors we will never name. Storms older than our species. We are made of the same atoms that fall as glass on HD 819733b, silicon, oxygen, carbon, and stardust. Every silicate particle in those alien clouds was forged in a dying star, long before our sun existed. The same is true of the sand on every earthly beach. We share an origin with the storm. The same physics, the same chemistry, arranged into a softer, kinder world. A statistical miracle, perhaps. That perspective is, in its quiet way, the real gift of these distant discoveries. Humility wrapped in wonder. If you enjoy these journeys into the cosmos, leave a comment with the strangest world you have ever heard of. Subscribe and ring the bell for more journeys into the deep field, where the universe shows itself slowly. Somewhere tonight, beneath a star called HD 189733a, a storm of glass is still falling sideways, and it always will.